You don't need to come with any sort of preconceived notion about these specific disease states. You don't need to know any specific content. It's just
George back for some more MCAT podcast, MCAT Blueprint, or Blueprint MCAT rather, Diagnostic Breakdown, Biochem Passage 3. Again, everyone gets the diagnostic for free at blueprintmcat.com. We went through Passage 2 last episode. We got to the end, we close our eyes, take a little breath, a little kumbaya, a little prayer moving forward. Please let it be something that I understand, that maybe I have a little bit of knowledge of. As we get to a new passage and we see a graph that catches our eye, or we see some words that we're like, uh-oh, I don't like this topic. What is your suggestion for a student who gets to that situation and they're like immediately turned off by the content of the passage even before jumping into it?
This is a great question, and we see it a lot. The biggest thing is block out the noise. Right? Block out the noise. You're going to see these big, ugly names, these disease names, these random genes. If you need to, just replace it with like a letter. Like in the previous thing, like GRDI says, just replace it with a letter G. Like some disease G is such and such and such and such. And it becomes a lot less intimidating. It's just a name. You don't need to come with any sort of preconceived notion about these specific disease states. You don't need to know any specific content. It's just some sort of name. If the figures, again, it's like something big, something ugly, everything's all over the place. Remember that the people who wrote the MCAT sat down and were like, okay, all of our answers make sense, right? The figure shows exactly what it needs to show to answer this exact question. If you have that confidence to know that literally everything you will need from the passage is right in front of you, it gives you a little bit more confidence in the sense that you don't need to focus on the big scary elements. Focus on exactly what's important. Focus on the MCAT testable stuff. Focus on the relationships. Focus on the variables. Focus on, how things relate to each other. Focus on those buzzwords like protein, amino acids, or like certain, I don't even know, organ systems, right? Focus on what you know and use that to orient yourself towards answering the questions.
But it's so hard to just want to judge everything by its cover and go, this is going to be a terrible passage, and then you live up to that judgment, unfortunately.
Oh man, but we'll see. I'm sure there will be examples today where it's like it's just that. Notice like how things relate and like all the fluff in between. You can change the name to whatever you want, and it doesn't matter, right? So,
yeah. All right. Well, let's jump in and we'll see how it goes.
Amazing. I thought this was a good passage too, because the moment I read the first sentence, I was like, I know where we're going with this. So, shall I begin?
Yeah.
Amazing. So a woman began canning her own jams as a hobby. She shared several cans of her jam with her mother for lunch. The next day, her mother was found suffering from blurry vision, difficulty swallowing, and troubled breathing. Given the quick progression of symptoms associated with the new food, the ER physician suspected botulism poisoning. Due to the danger and toxicity of botulism, tests were performed immediately to determine the best course of treatment. So I look at this paragraph, and again, it's like, identify what's important. Granted, I think this is one of the more palatable paragraphs. Like, it doesn't seem too intimidating. It's like, we get some backstory, we get something that happens, but I might focus again on the MCAT testable stuff. I know I was given a list of symptoms, so I might highlight the word symptoms and just remember that there's something involved with vision, something involved with swallowing, something involved with breathing, maybe giving myself a primer of the kind of systems involved, and botulism poisoning. I think this might set us up. We're probably going to introduce an organism, maybe like some sort of toxin as well. But really, that's like all the important stuff from this paragraph. The rest is just kind of fluff. Moving on to paragraph 2, the botulinum toxin is a neurotoxin produced by the bacteria Clostridium botulinum. Botulism is a life-threatening illness in humans, although forms of the toxin are used for various cosmetic and medical procedures. The 8 distinct toxin types are designated A to H. The botulinum toxin protein is a 2-chain polypeptide with a 100 kilodalton heavy chain joined by a disulfide bond to a 50 kilodalton light chain. This light chain is a protease that attacks one of the fusion proteins. quote unquote snare proteins at a neuromuscular junction, preventing vesicles from anchoring to the membrane to release acetylcholine. So now we're starting to get into some more like cellular level stuff, some more mechanistic stuff. So the first thing that I see, okay, we're continuing along this idea of botulism. We're introduced to this toxin, understandable. I'm going to highlight neurotoxin. This might tell me a little bit about, what systems are involved, maybe some questions about the brain. I'd highlight neurotoxin. And then I'm also scanning. I see, okay, it's related in like, it's a toxic thing. It's used for cosmetic purposes. Hilarious, right? This is where Botox comes from. You think like humans, like this is super poisonous. Let me put this in my face. So you're like, great, fantastic.
It's all for the gram.
Just for the gram, exactly. And then we come across this idea of distinct types, right? Okay, so we have different types. Great, not a lot of too many details. Again, I'm looking for these MCAT testable words. When I see 2-chain polypeptide, I'm thinking of all the protein questions that they might ask me. So I'll just highlight 2-chain polypeptide, and I see there's some properties about, a heavy light chain. I'll just keep that in mind. I also see disulfide bond. I'm like, that's super MCAT testable. Maybe they'll ask me about reducing or oxidizing conditions. Maybe like, wonder what conditions would proteins denature, such and such like that. And then this idea of this protease. So I might highlight protease. This light chain is a protease, and it ultimately prevents vesicles from releasing acetylcholine. So this is what I mean by those relationships are important. We've introduced something, it's some sort of protease, and this prevents. What's the action? What's the cause effect? It prevents the release of acetylcholine. So I'd probably highlight here preventing release acetylcholine. Just to give myself an instance of this entire setup, that's all I need to know, right? We're going to prevent this release of acetylcholine. Great. Looking at this figure, it says mechanism of neuromuscular blockade by botulinum toxin. Really, to me, this just seems like a graphical representation or like a diagrammatic representation of the previous paragraph, or like, yes. So kind of talking about what goes on and how things interact and how it ultimately impacts acetylcholine. So just making a mental note, don't need to go too much into detail. It's there as a representation. Moving on to paragraph number 3 now. So tests employed to detect botulism include brain scans and nerve conduction tests. Toxicity testing of serum specimens, wound tissue cultures. Toxicity testing of serum specimens, wound tissue cultures, and stool specimen cultures are the best methods for identifying botulism, though they are time-consuming. If the symptoms are diagnosed early, treatment can reduce fatality to less than 20%. A faster way to detect the toxin in humans is using mass spectrometry. I also realized I read wound. It should be wound tissue cultures.
Yep.
But again, in this idea, it's like, what new stuff are we getting? Right now, we're getting more into the clinical aspect. So I think the key focus of this paragraph is those keywords: detect botulism. We're going to run some tests. We're going to look for botulism, right? We've introduced some things that might be a little slower, and we end up with this new technique, mass spec, which is a little bit faster. Great. I might also highlight this idea of if it's detected early, you can reduce fatality to less than 20%. Maybe we'll get an important question there. But this idea of detecting botulism, so I know if I have anything to do with detection, I'll come back to this final paragraph. Mm-hmm. So moving on to the questions, or before we get to the questions, any thoughts, comments on this passage so far?
I thought they were going to say one of the best methods for identifying botulism is raising your eyebrows, and if they don't move, then you're infected. Yeah. This seems pretty straightforward, which scares me because straightforward usually means harder questions. But
questions, yeah.
We shall see.
Let's find out.
So, question 11 here. I'll start. What is a likely neurological symptom caused by the toxin's effect on acetylcholine release? So, again, we kind of know. I think just based on what Botox is used for, it's to relax muscles, and that to me is flaccid paralysis. That's the only one, right? Tetanus doesn't make sense. Muscle spasms is kind of like tetanus. Nausea, no. So I'm going to go with flaccid paralysis because that's the whole point of Botox, is to relax the muscles.
Flawless. That's exactly it, right? And this is also why if you can make those connections, you can make these like the application, the strategy, the approach. I think one area that this question could be challenging for people is if you read the question too quickly. I think the first time I read this question is, what is a likely neurological symptom caused by acetylcholine release? In which case, acetylcholine release is actually associated with muscle contraction, muscle spasms. So I'm like, oh, we're flooding acetylcholine. It must be like tetanus or muscle spasms. But I'm like, wait, they can't both be true.
Yeah.
The key to this question is caused by the toxin's effect on acetylcholine release. And from our understanding of the passage, the toxin effect is to prevent acetylcholine release, in which case we would prevent muscular contraction, just like you mentioned with the actual toxin, Botox, putting in our face so we can't move it. Flaccid paralysis would be the correct answer.
Nice.
Amazing. Question 12. So the easiest method to separate the two subunits of the botulinum protein for subsequent analytical purposes would be what? A, gas chromatography. B, mass spectrometry. C, thin layer chromatography. Or D, size exclusion chromatography.
So, easiest method to separate two subunits of the botulinum protein. And I come back here, right? Protein 2-chain polypeptide. We have a heavy chain and a light chain. I'm assuming that's what it's talking about, separating those two things. Now, we did highlight disulfide bond. And I'm like, okay, well, is any of these have to do with anything? But these all look like, I don't know. Not anything to do with disulfide anythings. But we do have a really big thing and a small thing. And so I'm like, the only thing that has big and small is size potentially or mass. And so I'm like, is heavy mass, light mass? That's what I'm going to go with, mass.
It's a very good thought process. Unfortunately, the correct answer is D.
Oh, it is size. Okay.
Let's talk about this. Your approach was flawless, though, because again, with this question, we're talking about the two subunits of the botulinum protein. The first thing, in terms of strategy and approach, every time you're faced with a question, you're like, what do I need for this question? I see there's two subunits. Where did I see the two subunits? What's different about them that will lead to separation, right? So perfect. You went back to your highlights. This is why the structural highlighting is super important. We see, okay, there's a 2-chain polypeptide. There's two parts to it, two subunits. One is a heavy chain, 100 kilodaltons. One is 50 kilodaltons. There's a big difference in the size or mass, right? Both are valid. There's a difference in size. So when we look at this, size exclusion chromatography would be the correct answer. Based on just chromatography, if we talk about chromatography to begin with, chromatography is a technique to separate things. Spectrometry is a technique to kind of measure things, to classify things. So it's also tempting because we saw mass spectrometry at the end of the passage, right? Yep. They dropped it in there and you're like, well, if it's good, like maybe it's multifunctional. But in this case, it was a test to detect botulinum, to detect the actual presence of the toxin, not to separate it. So mass spec at a short, it like blasts a bunch of ions, it breaks it up, and ultimately you can figure out the actual size and maybe a little bit of the properties of the compound you're looking at, but it doesn't give you any separation. In terms of the other separation methods, so gas chromatography, thin layer chromatography, and size exclusion chromatography, thin layer chromatography is the classic thing that you'll see in your organic chemistry lab. You have those little silica plates, you put it in like a solvent of some sort, capillary action comes up and like the compounds move with it. It's based on polarity. Gas chromatography also separates things, but as the name suggests, in order to separate it, you have to turn it into a gas. You have to vaporize it. Our botulinum protein is a protein. Have you ever heard of a gaseous protein before? Like, if you try to vaporize it, it'll be destroyed. You won't really have it, right? Yeah. So you need to be able to turn it into a gaseous phase, usually volatile substances, organic solvents, that kind of idea for gas chromatography. So in this case, size exclusion chromatography, in the name itself, size exclusion based on size, chromatography separation. Separation based on size. D would be the correct answer.
It was such a dumb mistake too. I didn't look at the second word, mass versus size exclusion. That I just went on that. I'm like, well, mass, heavy, light, and like mass spec. Like I loved mass spectrometry from my organic chemistry and biochemistry days. Like I was a savant at those things. Yeah, I could look at it and draw the molecule in like a minute. Like. And I remember having a lab. I talk about this every once in a while. And I think it was organic chemistry lab. Being in a lab, and one of the quizzes was you were given two mass spec kind of layouts, whatever, all of those little spikes. Yeah. And it was a test, and it was like an hour-long lab to figure out what these were, and I was done in like 3 minutes. And I was like, "Can I leave?" And they're like, "No, you have to stay half an hour." I'm like, "What do you mean? Like I'm done." And then they marked me off on one of them. And I took it to the professor, and he's like, "You're better at these than the TAs are in the lab." And he was like, "Yours is right." So, for some reason, there's just something about just. It just clicked with how my brain works to see these little spikes and go, "Ooh, I know what this is, and I know how this affects, and because this is a ring and it pulls this that way," and yeah, it was really fun. So that was just a stupid mistake. I was going too fast.
No worries. I mean, I think to your point, a lot of people look at the MCAT and they're like, "Oh, it's intimidating, so much content." But I'm gonna tell you right now, my biggest motto in life is that learning is fun when you know what's going on.
Yeah,
it takes time to get there. I'm sure it took you time to like learn the mass spec at the beginning, but once it clicked, like it's the same thing with organic chemistry, nomenclature, whatever it is. When you know what's going on, it's so fun to see everything click together, and you're like, "This makes sense.
Yeah.
This makes sense. I don't really need to think about it or like memorize it. It's like it logically makes sense. It's like a language, right? Things fit together. You look at this like, an NMR or, a mass spec sheet. In medical school, you're going to look at things like ECG. So these little waves about like, your heart information.
Yep.
And for most people, you look at it and you're like, huh?
Well, EEGs, right? We used to call them, they're just like squiggles. And my
like,
wife is a neurologist, and she always thought they were squiggles until she actually learned how to read them. And she's like, "Oh no, they actually tell a story here."
And that's exactly it, right? And like I think it's so satisfying to actually look at it and be like, "This is exactly what's going on." And like everyone around you is like, "How did you? How what?" Like,
well, it's like when Neo finally sees the Matrix. He goes, "Oh, like, I got
Amazing.
it. I got it."
Yeah.
All right.
Awesome.
Question 13. Which molecule could be used to detect toxin D in the cultures described in the passage? A, an antibody, B, a phospholipid, C, a radio-labeled thiamine, or D, an antigen? All right. So toxin D in the cultures. So we have 8 distinct toxins, A to H. I don't remember specifically learning about toxin D. So that may just be throwing us off, right? Maybe I think they just want to know, like, how do you detect this thing? And culture, I'm assuming that's talking about a blood culture. And we have here, right, or stool specimen culture. Which molecule to detect toxin D? And so again, we go to toxin, right? The toxin is a 2-chain polypeptide with blah, 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 blah. And so how are we going to find this thing? Antibody doesn't seem like antigen, antibody to me are like one or the other. Is it going to attach itself to something? And if it's a culture, I don't know. Like detecting something to me, like I immediately go to C because I'm like, ooh, radio labeled. Then you can see it if it attaches, it's radio labeled. So with antibody, right? An antibody, I'm gonna go attach myself to something, right? I see this foreign thing, it's an antibody, I'm gonna go get it and attack it. And antibodies, I suppose we can have fake antibodies maybe and go attach like out of a body in a culture. I'm trying to think of like real life scenario where we use antibodies outside of the body. Oh man, it's been a while. Antigen, again, like we give an antigen so that an antibody will do something with it. So like to me, those are just too similar but different to pick. Phospholipid. Can we go to this? I'm gonna go with radio-labeled thiamine because I'm like, radio-labeled things are what you use to find things.
Fair enough.
I don't know.
Right? What I gotta tell you, you've fallen into the trap. So the MCAT knows that that radio-labeled things are used for diagnostics. So this is where the tough part is. So I know there's a lot of things that they'll give you that are tempting, but this is why sometimes like we do need to have the foundation. So if we break through this, if we look at just consider, toxin D, like you mentioned, we didn't see any specifics about toxin D, but it is one of the 8 distinct types of toxins. And we know that ultimately this is a protein. So we're working with some sort of unique protein here. So if we paraphrase it, what can we use to detect some sort of unique protein? When it comes to these macromolecules, so we see like phospholipid. Phospholipids are very classically found in our membrane. You have a polar, non-polar part. The non-polar parts stay together, the little tails. The polar parts face out and in, right? It's part of our membrane. It's not really used for targeting proteins, not used for detecting proteins.
So it is an antibody.
It would be an antibody, yes. So let's break it down, right? If we look at the second part of the radio-labeled thymine, what is thymine? What's thymine?
It's a thingy in DNA.
Yeah, it's a nitrogenous base, right? It's a thing in DNA. Does DNA, does a nitrogenous base on its own, is it known to interact with kind of like proteins, just mark it on its own? Not really.
No, but it said radio labeled, and that was sexy.
Yeah, right, exactly. But remember, both parts need to be true, right? So you fell right into the trap. So if we come back to this distinction between an antibody and antigen, just kind of like you said, the difference is an antigen is like a part of a protein, a chunk of a protein that is capable of being
like the spike protein of coronavirus, which everyone knows about. Yeah.
But I love that you're making examples like that. That's exactly it. Like with an antibody, it's the same thing as in like, I like to think of them as these little Y structures with these, like the tip of your fingers, they go around. This is the unique area and they stick to things. They stick to very specific and unique parts of proteins. They stick to antigens, right? So in this case, when we're trying to detect for a specific protein, on the tips of their antibodies, we have a very specific like complementary site. This is what's going to stick onto your toxin D. So it's the antibodies that will go stick onto your antigen on the toxins. You wouldn't use an antigen to detect another antigen. You'd use an antibody. Yes. So in a lot of diagnostic things like ELISAs and like all of that kind of stuff, they use antibodies to go bind the thing. And they use a secondary antibody to bind the first antibody, which has some sort of radio labeled component or fluorescent component, so that you get a signal to see that that what you're looking for is there.
Why was I overthinking this? And I'm like, well, it's a culture. And I just, for some reason, like in my head, I'm like, well, antibodies are in our body. We're not using them outside of our body. Why was I overthinking that?
Because the MCAT puts the information there to distract you, right? And I think like it's a very common thing. People will look at, and it's like what we talked about in the beginning. It's easy to get distracted by, like, in this case, it was words that we understood. We know what a culture is. We know, like detection, toxin, like we see it all together. But this is why paraphrasing and distilling the question to something simpler makes your thought process easier. Instead of looking at it as in like specifically detecting in cultures something about the passage, this question, all it's asking is, how do you detect protein, right? How do you detect protein? What do you use to detect protein? Antibody, phospholipid, radiolabeled thymine, or an antigen. So in this case, it's like, even though we want to get distracted in this, like, oh, like the culture is important, oh, like toxin D is important, all of this is, really distill it down to the only thing that's important. How do we detect protein from these molecules that we've been given? And the correct answer would be an antibody.
Body yada yada yada. No. Oh man. All right. That was just silly. Okay.
No, you got it. It's all good. All good. The whole point of making these mistakes now is so we can learn from it, right? It's the same thing. There's never any shame in taking a diagnostic, never any shame in getting a question wrong. When you learn the right way, you'll actually know it when test day comes. That's what matters.
What'll really blow your mind is I could actually get a 528. I'm making all these mistakes on purpose so that students will learn from me.
Amazing. So question 14, right? This is like very high yield stuff. So let's talk about this. Which of the following is not a function of the sympathetic nervous system? Increased heart rate, pupillary constriction, vasodilation, or vasoconstriction?
So this is called a pseudo-discrete.
Absolutely. Does it have anything to do with the passage?
Well, kind of, but not really.
Kind of. But like, do you really need the passage to answer this question?
No.
Not at all. Exactly.
Yeah. So I always like to think of sympathetic, parasympathetic, right, as the point and shoot, right? kind of relaxation point, and shoot is doing, like the action, like doing something, whatever that is. And so if we look at the sympathetic, right, fight or flight kind of get the body ready to do something. So increase heart rate. Yeah, that makes sense, right? I'm getting ready to do something. I need to increase my heart rate, go deliver oxygen to places it needs to go. So we have to make sure, right? This is a not question. So I'm gonna highlight that. So what is not a part of the sympathetic? Well, increased heart rate is a part of the sympathetic, so I'm gonna strike that out. Pupillary constriction, I'm gonna strike that out, right? We're gonna constrict our eyes. We're gonna get more focused on what we need to run away from our saber-toothed tiger. And then C and D, we could have potentially come down to these two right off the bat because, well, they're opposites. So one of them has to be wrong and one of them has to be right. So we could have potentially striked out A and B to begin with. So again, if we, process of elimination, increased heart rate, pupillary constriction, vasoconstriction of like, got to get ready, let's shunt blood where it needs to go. That to me seems like, well, that's also part of this process. And so we're left with C, vasodilation, which is part of relaxing. We don't want to relax when we're fight or flight.
It's a good thought process. Although I have to tell you, I'm going to challenge you on one idea here. I really like the distinction between the fight or flight and the rest and digest. That is the classic, I always think parasympathetic. I've had a big meal. I'm impaired because I have a food coma. Parasympathetic, rest and digest. Sympathetic, fight or flight. In this case, like you said, that saber-toothed tiger, if it's standing before you, do you want to see him better or do you want to see him worse? Do you want to take a really good look at him, or like do you want to not see him so well?
Oh, I don't know.
Like if you're trying to like you're activated, you're nervous, you're fear, you want to size up your opponents, are you going to see him better or worse? What does your body want to do?
Better.
Your body's going to give you more information.
Yeah.
So if you think of your eyes like lenses, are they going to open up or are they going to close? You want more information. It's not, I know what you mean by maybe constricting gives you a sharper image, but do you want more information or less information?
I understand your question, but I don't understand your question.
Sure. So what I'm getting at here is that in fight or flight responses in your sympathetic nervous system, your pupils will actually dilate. So what happens is you want to get the most, you want to see what's going on. So your heart starts pumping, your eyes like widen because you really want to get a sense of your environment. So when we talk about which is not a function of the sympathetic nervous system, pupillary constriction would not be a fight or flight response. And so let's come back to this idea of vasodilation and constriction. I really like your approach when you're saying, oh, like they're opposite processes, they both can't be true. But remember, when we do fight or flight, where do you want your blood to go? Let's talk about that first. When you need to run, you need to fight, where do you want your blood to go?
All right, now you're pissing me off here because obviously when you're shunting blood to places, your vessels are constricting and dilating based on traffic flow, where the blood needs to go. So both are happening.
Exactly. That's the key, right? If you need to run, your vessels in your muscles are going to dilate because you want blood there. But where are they also going to constrict? You're going to take away your stomach, your viscera, your internal organs, because you're like, honestly, I don't need to digest my sandwich right now. I need to get the heck out of here. So you're actually going to vasoconstrict in your gut, in your belly, and you're going to vasodilate in your muscles so you can flee. So this is why C and D are part of the sympathetic nervous system. It's a common misconception to think that sympathetic is activate and parasympathetic is like deactivate. But remember, they both activate and inactivate depending on the targets that they have. So when we have this idea of fight or flight, like it would be the pupillary constriction that's not part of it because you want to open your eyes, you want to see, you want to size up your opponents. That's why in this not question, which is not a function of the sympathetic nervous system, pupillary constriction is not a function of the sympathetic nervous system.
It got me.
Tough question. Like, this is what I mean by like, sometimes like your logic was perfect in the sense that you were looking for the parallelisms. You were thinking, okay, well, if one's true, the other one can't be. A lot of cases that is true. The difference in this case is that because there are different targets, some of them can be dilated, some of them can be constricted at the same time, right? You want to shut down, you want to constrict the blood going to your gut, you want to dilate the blood going to your skeletal muscles.
Oh, man.
How do you feel?
Dumb.
No. This
Dumb.
is like, these are, it seems like, and again, it's easy to get discouraged over these questions because you're like, wow, like sympathetic nervous system, parasympathetic nervous system. I've seen this a million times.
Yeah.
Again, make the mistake now. You're never going to make it again on your test day. Like, you're going to kick yourself. You're going to review it. You're going to look at it, and you're not going to. I honestly, in my first clinical skills, the most embarrassing thing is I was like working with a patient, and I put the blood pressure cuff on backwards. So when I was inflating it, it would just like, it started ripping off the Velcro. Like, it started coming undone. And I literally readjusted it 6 times. And I was like, I'm so sorry. Like, I've done this so many times. I don't know what's going on. And I had to look at my tutor, who wasn't supposed to intervene. Like, they're not supposed to give you feedback, but he's like, listen, I have to jump in because like you weren't gonna get this. Like, you have the blood pressure cuff on the wrong way. And I was like, I'm so embarrassed. But to this day, I know for sure, like every time when I check my blood pressure cuff, I know exactly which way it's supposed to go on, and I'm never gonna make that mistake again. So make the mistakes now. Don't kick yourself too much over it. It's okay to make those mistakes. It's okay to learn from it, and that's what's important.
Oh, you're so kind. I'm still dumb.
Oh my gosh.
All right, I'll read this last one here.
Sure.
The symptoms of botulinum take 12 to 18 hours to be observed in the patient. How is this best explained? A, growing bacteria produce the toxin. B, botulinum toxin is immediately filtered by the kidneys and excreted. C, toxins can be absorbed through mucous membranes or respiratory tract. D, most of the toxins are polar and they take time to cross the nuclear membrane. So we know that, I think, I'm going to second guess everything, and this is the problem that comes with the MCAT.
Leave everything behind. Leave the mistakes behind. Take a breath.
It's a new question.
New question.
We know that the toxin is produced by bacteria, right? And so it's not like we ingest a million molecules of toxin and that's what makes us sick. We ingest some bacteria. The bacteria get into a situation where they can grow, divide, blah, 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 and they're releasing toxins. The more bacteria that are created or that grow, the more toxins are released. And that's where I'm just going to go with A right off the bat because it's just like the most logical. It's going to take a while to get to a level of bacteria in our system that's going to produce enough toxin to make us sick.
I really like your thought process. Unfortunate. No, I'm messing with you. A is the correct answer. Okay. A is the correct answer.
Don't do that to me, George.
This is perfect. So if we actually go through the other answers, we'll see whenever we come across a question, we want to make sure that 1, the statement is true, and 2, it applies to our situation.
Yep.
So here we see symptoms take time. There's a delay. Basically, what causes the symptoms delay? That's what the question's saying. I'm paraphrasing. What causes the symptoms delay? So we're looking for an answer that is true physiologically and also causes a delay. It has to be true. It has to apply. So growing bacteria produce the toxin. Just like you said, you ingest a little bit of bacteria. Maybe at first, like it's not enough. If you start growing, they start multiplying. You get more and more. You get more toxin. Makes sense. It takes time for them to grow. We'll keep that in the back of our mind. Botulinum toxin is immediately, so B, it's immediately filtered by the kidneys and excreted. If you immediately get rid of your toxin,
then you're not going to be affected by it.
You're not going to be affected. Exactly. So it doesn't cause delay in symptoms. Actually, it would cause no symptoms if those were the case. B is not the correct answer. Toxins can be absorbed through mucous membranes or respiratory tract.
Okay. Maybe.
Okay. Like this is probably true, right? But it doesn't cause a delay. If it was absorbed in your mucous membranes, remember your mouth has mucous membranes. If you just ate something and it started getting absorbed through the mucous membranes, well, it can be immediate. By that logic, you'd be affected immediately, right? There wouldn't be any delay. So this might be true, but doesn't apply. D, most of the toxins are polar, maybe, okay, and they take time to cross the nuclear membrane. If we think about like polar versus non-polar things, the classic thing to remember is that anything intracellular to get out from extracellular to intracellular, it has to be non-polar, right? Non-polar things like your cholesterol, or like your steroid-based hormones. These are the things that are going to come across your membrane, go towards your nucleus, right? Which big toxin is ever going to cross your membrane and get to your nucleus? None. The other thing too is that our toxin, they specifically mention, acts at the neuromuscular junction, so outside of your cells. So it doesn't actually go in, it doesn't go to your nucleus. We can get rid of D as well. So in this case, if you go with your gut and you find the correct answer, you don't have to go through the other ones. But for the sake of completeness, B to D are incorrect for the reasons we mentioned. A is the correct answer. Growing bacteria produce the toxin. It's true and it applies.
Yeah.
How do you feel?
Miserable, but and you did not help with that last one. But it was one that I kind of expected going in, right? We read the passage. I'm like, okay, this doesn't seem too confusing. And then I rushed some of the questions, and it could have gone a lot smoother, but it didn't. And that's okay.
So yeah, we just got to read the questions carefully sometimes.